All right, Sufyan. So, yes, good evening.
Mhm.
This extra class has been substituted. As I've told you, we just have one portion to discuss, so that this entire portion is over. All right. So, because your exams are coming, the main issue is regarding the exams. Now, second chapter and third chapter we'll be doing in our regular class, and this chapter you will be doing with another batch. So that will be your extra classes, okay? Because you
Mhm.
have to manage for this. Is it fine, Sufyan?
Yeah.
Okay. Let us start with this. See, this is an arc. Now again, we'll divide it into four segments. This is the first segment. This is the second segment. This is the third segment. And this one is the fourth segment, right? Now, this is an arc. Whenever we have such type of questions, mixed question, net magnetic field is B1 plus B2 plus B3 plus B4, right? This is how we have to use it. So B1 is an arc. This is not a complete circle. This is not a semicircle. So this is just an arc with angle pi by 3 at the center. Mu naught I, right? The current in through the entire wire is I. Basically, our wire is like this. This is the wire which is given. So this is what we are solving by dividing it into parts. So this is the wire. So mu naught I alpha. Alpha is pi by 3. 4 pi radius is 2r. Radius here is 2r. So pi cancel. Okay, now this is clockwise. So clockwise inwards, which is minus k cap. B2, this is exactly on the axis of this, right? So this is 0. Plus B3, again an arc. So mu naught I pi by 3 because angle is same, but radius is r. So 4 pi r, right? So this is now anti-clockwise. So outwards, k cap. And again, this is exactly on the axis. So straight away 0. So what do we have now? We have mu naught I pi here got cancelled. So this is 6, 4, this is 24 r minus k cap plus pi cancel mu naught I by 12 r plus k cap. This is the answer, this much of test. Write down this question.
I'm done.
Now, see, Sufyan, what's this exactly? If we had talked about circular loop, right? In the circular loop, this is what we've studied, that this is the circular loop. At the center, exactly at the centermost part, we have the formula as mu naught I by 2r. That is our formula. If this is a semicircle, then we have the formula as mu naught I by 4r. Now, what if at this axis I don't want, at the center I don't want the magnet? This is the axis, right? What if I want the magnetic field to be present over here at this point on its axis, right? That is what is given. So this is the xy plane. This will be the yz plane. So this is basically kept in the yz plane. Okay. So this is kept in the yz plane. This is a ring of radius r. Now, when we take out the segments, this DL segment, this is always perpendicular. All right, this is perpendicular, or you can say this is tangential. This is tangential. Now, radiuses are this axis separation. This is x. Now, when we are calculating this hypotenuse, it is under root capital R square plus x square. Similarly, this side also, this is under root R square plus x square. All right. So this is at the center. Now, here it is theta, this is theta, dB is this angle. Now, what do we have? We have the angles which are present. So here the angle is, here when we are calculating this angle, this is theta. This is 90 degree. So this becomes 90 minus theta. This total is 90, so this becomes theta. Again 90 minus theta, 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 and like this. Why? Because from both of these diametrically opposite ends, I have taken the magnetic. Fine. Now our purpose, our work is to resolve these magnetic fields because these are in random planes. We want the magnetic field to be either along x-axis or y-axis, right? So this will be here, this is going to be dB cos theta, and the perpendicular one is going to be dB sin theta. All right. And again, this is our magnetic field. So this is going to be dB cos theta, and perpendicular one is going to be dB sin theta. All right. So sin theta and cos theta, this is what we have. Now Sufyan, look at this. These are just two magnetic fields, basically two current elements taken on the opposite, diametrically opposite ends, right? So if they are having the resolution like this over this point, if I take any other 2 points from here, if I take any other two points from here, any 2 points from here, which are diametrically opposite points, right? So still we will get the same answer, right? We will get our same answer of this derivation. Why? Because what will happen? All the sine thetas will be cancelling each other, and all the dB cos theta will be pointing in the same direction. Do you agree with this, Sufyan?
Yes. Yes.
Right? So even this is just a derivation from two diametrically opposite ends. For all the ends, we'll be having dB sin theta and dB cos theta aligned like this. So net magnetic field along y-axis will straight away be 0. Upwards dB sin theta and lower dB sin theta will cancel each other, and all the dB cos theta will be pointed towards the same end. All right. So here if we go along y-axis, dy, so dB sin theta minus this integral of dB sin theta. So they'll cancel each other. This will be 0. So your total magnetic field along y-axis from any two diametrically opposite ends, this is going to be 0. Fine. What about the x portion? Basically, bx, this is integral of dB cos theta. So we need two things now. We need cos theta and we need dB. Right. So see, for dB, magnetic field, we have the Biot-Savart's law already. And theta is 90 degree, as the radius always makes 90 degree with the tangent. And tangent is only 90 degree. So this is mu naught I dl. This is sine 90 degree by 4 pi r square. So this is equal to mu naught I dl by 4 pi r square. This is the dv portion, right? Now you tell me, Sufyan, in this triangle which we have, this is theta. What will be cos theta? We have three things: r, capital R, small r, and x. What will be cos theta, Sufyan?
R by root of r square plus x square.
Which one?
R by root of r square plus x square.
Very good. Capital R by small r, right?
Yeah.
है ना? Capital R by small r,
And
correct.
C small r.
Yes, which has this value, correct. So since cos theta is r by r, now we have both the things ready. dv is also ready and our cos theta is also ready. So dv also we input mu naught I dl by 4 pi r square, and cos theta also we are going to put, that is capital R by small r. Now this is our net magnetic field, this is our answer. Now we just have to simplify it further, right? So if we write all the constants together and all the variables together, this is mu naught I capital R by 4 pi small r whole cube, and we are just left with integral of dl. When we were doing the derivation also of this integral of dl, that time also we had discussed, if a circular loop is there, what should be the integral of dl, Sufyan?
Circumference to 2 pi r.
Yes, integral of dl for a complete circle. If we add all
2
the
pi r.
dl together. Yes?
2 pi r.
2 pi r. Very good. 2 pi r. Yes. So mu naught I r by 4 pi small r cube into 2 pi r as rightly answered. Pi gets cancelled. 2 and 2. So what are we left with? We are left with mu naught I capital R square now. R into R divided by, this is 2 small r cube. Now let us put the answer which you were saying, no, value of small r cube. We know small r is equal to under root capital R square plus x square. Let's put it. Or one more thing, Sufyan. R can be written as capital R square plus x square to the power half. Root can also be written like this. Now see, what is our net magnetic field? Mu naught I capital R square mu naught I capital R square divided by 2. Now this term, that is R square plus x square to the power half into the, it's like half to the power 3, which is 3 by 2. So this is the formula which you have to solve. N number of turns, you'll just simply multiply it with n's. For n number, what you are going to do? If it is n, then net magnetic field at the axis is written as n mu naught I r square by 2 r square plus x square to the power 3 by 2. All right, this is what we have to write. Write down this derivation. Keep on updating me in the chat column. Start writing from here. See, Sufyan, how to solve this question. Basically, we have two rings now. They are in different planes. Which plane is this? This is YZ plane. And which plane is this? This is XZ plane. That's the only difference. Now, let us talk about the net magnetic field. Net magnetic field will still be B1 vector plus B2 vector. So, B1, this is mu naught I capital R square. Capital R square is the radius. So, B square by 2. Capital R square plus X. Here it is also X square to the power 3 by 2. Now the direction. See, current is coming from outwards. It is coming and going inside, right? From outwards, it is going inside like this. It is coming outwards and it is going inside like this, right? See, current is coming and it is going inside. So, this is our negative x-axis minus I cap plus. This is mu naught I a square by 2 a square. 2a square plus x square to the power 3 by 2. Now the directions. See, this is coming like this, right? This is coming like this. So thumb is upwards, which is J. This much Tesla is the answer. Write it down. Done. Just text me done, Sufyan, once you have completed.
Okay.